Hello everyone, today we are building a block search system using FastAPI and Elasticsearch. By the end of this tutorial, you'll have a fully functional search API that can handle full text search, filters and relevance scoring. I'm going to show you the Swagger Docs UI as a sample of what we're going to build. We have this search API where we can filter by a query, we can filter by the author or by the status. I can enter a query and I will enter test for now and execute this query. And now you can see we get 7 results of blocks. In this instance, we are using blocks as the sample and we can search for the title. You can see I have different blog posts here and we can search for different titles or different tags inside of the blog post. I will now filter for this title, for example, and we get this one returned. Like you can see, we get different results for different queries. I can just filter for full text, for example, and I get 3 results, all done by Elasticsearch. We also have endpoints for showcasing how you can add blog posts to Elasticsearch and index them. We can list different blog posts from Elasticsearch and our DB because we're also saving them into a Postgres database. And Elasticsearch is the standard, or a big standard for search engines. It's used by big companies like Netflix, Uber, or GitHub. And combined with FastAPI, it's a good solution for a search engine or modern web applications where you need search. So I will showcase you how Elasticsearch works and how you can set up this project. So what is Elasticsearch? It's a distributed RESTful search and analytics engine built on Apache Lucene. And think of it like a database, but optimized specifically for search. The key points of Elasticsearch is the inverted index. Normal databases have an index by row, but Elasticsearch creates indexes inverted, mapping terms to documents. So you have a word, and this word is mapped to a document. It supports full text search, manages typos, and scores by relevance, and allows to query for, or allows complex queries. It's fast and near real-time search and indexing, and it can be scaled horizontally. Traditional databases can do basic searches with like queries, for example, but they are slow and limited, and Elasticsearch helps in this case. For example, it has typo tolerance, so you can do fuzzy matching. So if your query has a typo, it will account for that and still score this blog post, for example, which has a typo. It scores by relevance, so you will see the most relevant result first. And it's really fast in search, like you have seen. At the beginning, I showcased you how quick the search was. I have now opened the project. Here you can see the dependencies, which are quite slim. You would only need Elasticsearch and the FastAPI dependencies. I also use SQL Alchemy as the ORM for Postgres database and the async PG driver. I start Elasticsearch with a container. You can see I have the Postgres container, I have the Elasticsearch container, and I have Kibana, but we are not going to show this one. I just have this. The relevant parts are this one. I also seed some data, which I will later show you, where I will seed some sample blog posts, and we can directly jump into the code. This is the main FastAPI, like you are used to. We have the DB model, which is a simple blog post, and we have a title, content, author, text, status, views, and the published date, created at, updated at. We also have the schemas for the endpoints, so you can see what you can query and what you get returned. Then we have the database, where we just create a simple async engine and init the DB and have a getDB endpoint, which we can use a function which we can use as a dependency for our database. We have the config, where we load our environment variables with standard inputs like localhost, the index of Elasticsearch, and the database URL. I can show you the end file, where we have the same input and the URL to our database. Now I can show you the block router, which contains the Elasticsearch functions and the endpoints to create posts, query posts, search posts, update posts, and delete posts. Now, before I jump into the actual Elasticsearch logic in our code, I will quickly explain the core concepts. Elasticsearch stores its documents as JSON, and we have, like, the key terminology is like the index. It's like a database table. A document is like a row or a record in our database, and a field is like a column in our database. Okay, now I will explain how inverted indexes work. For example, we have the document, our first document, which contains the text the quick brown fox. The second contains the lazy brown dog, and the third the quick brown birds. And now we will match those terms to documents. So we have the first term, which is quick, and it's contained in our first document and our third document. Then we have brown, which is in all three documents. We have fox, which is only in the first, lazy, which is only in the second, dog, which is only in the second, and birds, which is only in the third. Now, if we search, for example, for our queries, for example, quick brown, it will return the documents 1 and 3, and also second because brown is also in the second. Now it will score those by relevance and will check, oh, quick and brown is together only in the first and the third. So both are in those documents, and will return them and rank them by relevance, like how close those words are together, for example. Now with that explained, we can jump directly into the code. We have, this is our Elasticsearch client. We init the client with our host and how many retries we want to have, and how if it can retry on timeout, for example. Then we will try to connect to Elasticsearch. In case I only added this logic in case our Docker container is not up yet, so I can just start both at the same time. Now we create the index if it's not existent. So this is the important part. We have a mapping and with the different properties. For example, we want to be able to search by the title, so we add the type text, and this is for full text search. We have the standard analyzer, so it will be tokenized and lowercase and this stuff. And then we also have fields like keyword. We can search by type keyword. This is for exact match filtering. So we want to if we only want to filter by one word, for example, and not like similar words. Then we can also filter for the content. There we don't want exact matching. We want to like rank and find if there's any similarity and return if the content is close to our query. Then we have our author. We want to filter for exact authors. So we only want, if we filter for author John, we only want authors returned with the same name. The same we do for tags, where we filter for keywords. By published date, we only want to filter by the exact date, for integer for the number, and for status also for the keyword. And then we use the Elasticsearch Python syntax to create the index if it's not existent. And if it's existent, we just print to the console that's already exists. If you want deeper understanding of that, feel free to search for Elasticsearch videos directly explaining its logic and not only in context of Python. So with that now explained, we can jump into our endpoints. The first one is a basic FastAPI endpoint where we have the response model of the blog post, the status code created if it's finishing, the post we want to create, and we get our async DB session. First of all, we create our model for the DB, add it to the session, and commit it and update. So we have the updated DB post in our endpoint available. Then we create the Elasticsearch client, and we index our index in our index and create the ID by our post ID and add the document to our index. So we load our document we just created into our Elasticsearch index. After that, we can just return the blog post so we can see what we created and with what ID to the frontend, or in our case, our Swagger UI. And if we have an exception, we roll back to the DB and return an internal server error, for example. Now we have where we can get one specific blog post by the ID. And in this case, we get our endpoint from our blog post from the DB. And if we want to, you don't have to, but we can update our views on our document. And after that, we do the same, return the blog post. We need to do that. We do this in case we want to score by how often this document has been viewed, for example. And if we get the document, it has we increase the views by 1, which you can see here, and we update DB. Next, we have a put request where we update an existing blog post. We can update. We have to update in DB and also update our index in Elasticsearch. And we return again. Now we have the delete endpoint where we delete the result from the database and check if it is actually deleted and commit. After that, we use the Python Elasticsearch syntax, which is really simple. It's just delete. We get our document by the ID and just delete it. You can add exception logic here if you want to, but I didn't do it just for this tutorial. And we return nothing because we deleted our blog post. Now comes the interesting part. This is the search endpoint I showed you in the beginning. We initialize our Elasticsearch client again. We have a search query, which I can show you. We can query by query. We have tags. We can add the author. We can add the status, and we can use pagination. So we can start from and the size of 10, for example. All right. So we build a query, for example, in this case, we have the must condition and the filter condition. So if we have a query, which I showed you the query field, we append the query with the search query. So we get it from our model, get the query, we rank the fields, we have the title, we boost the title because the title has more relevance than the content for this case. We use the type best fields, and the fuzziness is auto. This is what I explained in type. Because if we have typos, it will account for that and still search for the relevant terms. If we have tags, we will append the terms tags to it so we can get our query by the relevant tags. So it will exact match the tags. If we have the tags Python, we will only get blog posts with the tag Python in this case. The same for author and the same for status. And here we create our query clause. We have the must, where this is our must condition, where we append the query, where the title, and we have our filter condition, which is the tags, for example. You can see we append the tags to the filter and the author to the filter. And this is just, we use the must condition, and if we don't have must conditions, we just match all, so this will return all without a query. We order by score and descending, and by the published state also descending. Now we run a search. We have we search our index. We have our query clause. We have form and size. So we will only return all which are in this range, and sort by our sort clause, which is defined here. Then we will pass the results. We get we have a hit from the results. We get the hits. We can get the source. We append this to our posts, which we have here. We create a Pydantic model, which is this one. And we can return the search response with all our blog posts, and we have the total amount of which we returned and our actual results. And if we have an exception, we return an internal server error. Down here we only have an endpoint where we can get the blog posts which are not ranked by a search, so we can get all of the blog posts with pagination. Now that we have that, I will quickly jump into the Swagger UI and show you some different searches. In the repo, which I will post to GitHub, I have some sample searches, which I will now use and showcase. I can just paste this in here. We have the query Python async, the tags Python and async published from 0 to 5. We can execute that. We get with the tags Python async, Python, which you can see. We filter for the title Python async. We have async programming in Python. We get Flask versus FastAPI versus Flask, where we also have async in the title, for example. Python type and Pydantic, where we just have Python, which is returned. Building RESTful APIs with Python. And we can see our best result at the beginning, async programming in Python, which seems like the best result because our query was Python async with the tags Python and async. Now I will get another sample to filter. I will just copy this one and go back into the Swagger UI, paste it. This time we just query for Elasticsearch and get 10 results, or up to 10 results. Now you can see all the results. We can see how many views we have for that, for example. We can see our first blog post is Elasticsearch aggregations explained. And we could also filter for different tags in this case. We could filter for the author. And like you can see, this can be really expanded with different or more complex search queries and can have different use cases for blog posts, videos, or whatever you want to search through. When using this, make sure you run the Docker container with Docker Compose up, because I added the Docker Compose in here, which will all start that. Make sure you install all the requirements listed in the PyProject DOML. You can also use requirements.txt with a normal pip environment, but I use UV for it. Just make sure it's installed for the correct versions. The code is matching the correct version you have installed. And then you can just start up the FastAPI application. It will create migrations for the database automatically. So you don't have to run the migrations with Alembic, for example, but you can also do that if you want. So thank you for watching. I will upload the code to GitHub. And if you want FastAPI template, which you want to use without much boilerplate, you can feel free to check out my template, which includes FastAPI, Postgres, Redis, Docker, Stripe, Celery, and Alembic. So you can handle payments, you have a database setup, you can handle the background tasks. So feel free to check that out. And I will see you in the next video.